Hello friends, welcome to session 5 of time, speed and distance. We will continue with our discussion on relative speed, concepts based on the trains, and in this part 2 we will see some moderate to difficult level illustrations on relative motion. So we'll start with example 1 which reads that Rajdhani starts from Varanasi junction at 1 am and reaches Howrah at 11 am. Sampark Kranti Express starts from Howrah at 4 am and reaches Varanasi junction at 7 p.m. At what time the two trains meet? So, an important problem here. Let's see. First, we'll try to look at the problem pictorially. It says that there are two junctions, Varanasi and Howrah. So, Rajdhani starts from Varanasi junction at 1. So, let this be Rajdhani. So, it starts at 1 am, goes towards Howrah and reached Howrah at 11 am. Whereas Sampark Kranti Express starts from Howrah. This is for Sampark Kranti. It starts from Howrah at 4 am, 4 am and reaches Varanasi at 7 p.m. Here it reaches at 7 p.m. Right. So question is at what time the two trains meet. So now see, what is the time taken by Rajdhani? Time taken by Rajdhani is 1 am to 11 am, that is 10 hours, and time taken by Sampark Kranti is 4 am to 7 p.m. So 4 am to 7 p.m. means 4, 8, 8, 7, 15 hours. Right. So ratio of time taken by Rajdhani to ratio of time taken by Sampark Kranti is 2 by 3. Now since they are covering the same distance, so the speed will be inversely proportional to the time. So we can say that the speed of Rajdhani, or rather I represent it with V, velocity of Rajdhani upon velocity of Sampark Kranti will be 3 is to 2, right? Will be 3 is to 2. Now, as we had seen in our earlier discussion, now here are two parts of solving this, two ways of solving this question. One, since we have been given the time, exact time we know, 10 hours and 15 hours. So from here, from these two pieces of information, we can assume the distance, let this be d, assume the distance d is equal to LCM of the time, right? This method we had seen in our initial discussion on time, speed and distance. So this will be what, 10 into 15 is 30 kilometer. So let's assume that the distance is 30 kilometer. So what is it when distance is 30 kilometer? So with a time of 10 hours the speed becomes 3. So in that case velocity of Rajdhani will be 3 and velocity of Sampark Kranti will be 2 kilometer per hour, right? Same as what is this ratio, 2 kilometer per hour. Now, now see question, what happens? Rajdhani starts at 1 am, right? Whereas Sampark Kranti starts at 4 p.m. So for them to meet, what we'll do, we'll first try to see where Rajdhani is at 4 am. So by 4 am, that is at 4 am, 4 am, Rajdhani has covered what? At a speed of 3, and from 1 to 4, 3 hours. So that is 3 into 3, 9 kilometer, right? So out of total distance of 30, 9 kilometer Rajdhani has covered. Now, so what happens at 4 am? At 4 am, it looks like something this, right? The remaining distance to be covered is 30 minus 9, which is 21 kilometer. And here is Rajdhani Express, here is Sampark Kranti Express, both approaching towards each other, that is moving in opposite directions at a this moving at a speed of 3 kilometer per hour, this moving at a speed of 2 kilometer per hour. Right. This is the simple problem of a relative motion. So we can find the time of meeting. Time will be what? 21 upon 3 plus 2. That becomes 4.2 hours. 4.2 hours from 4 a.m. Right. 4.2 hours from 4 a.m. So that becomes 4.2. We can write as 4 hours, and zero point 0.2 means 12 minutes. 4 hours 12 minutes. So that means 4 a.m. plus 4 hours 12 minutes means that 8:12 a.m. they will meet in the morning, right? So this is the time when they will meet in the morning. The two trains meet, and this is the answer. So problem was, I mean, not difficult in a way. This is more of a conceptual in nature. We were given the starting time and the arrival time of both the trains. So thereby from there we could find the total duration of their journey. And since they are covering the same distance, so the ratio of speed, from the ratio of speed we can find the ratio of from the ratio of time we can find the ratio of speed, which will be just inversely proportional. Now since the actual times were given, we can assume that the distance covered was the total distance was LCM of the actual time given, right? And from there we calculated speed, and then so speed and distance we know. Now since the Rajdhani had started at 1 a.m. in the morning, Sampark Kranti starts at 4 a.m. in the morning. So to use the relative concept, we'll see where Rajdhani has reached by 4 a.m. So that we know Rajdhani had covered a distance of 9 kilometer out of a total distance of 30 kilometer. So now from 4 a.m. both the trains are moving towards each other. The remaining distance is 21 kilometers, so that we can find at what time they will be meeting, right? Otherwise, there's one more way of looking at this. Now see, if now see Rajdhani is here at 1 a.m., right? So 4 a.m. Rajdhani reaches here, covering a distance of, so suppose, I mean, whatever may be the distance, and then here 4 a.m. Sampark Kranti starts, here Rajdhani starts. Now since we know that the from this junction, now we will concentrate over this part. So Rajdhani and Sampark Kranti, the ratio of speed is 3:2, right? So ratio of speed is 3:2, and from this junction, that is, if we consider this point, say let this be M and N, so just M and N patch. So this patch, they will be meeting at the same time. They are starting at the same time, that is 4 a.m., meeting at the same time. So time traveled is same. So the distance covered will be just inversely proportional to their, sorry, so distance covered will be directly proportional to the speed. So here from M, Rajdhani will cover 3 units and Sampark Kranti will cover 2 units, right? Will cover 2 units. So from here also we can find that thing now, that if this becomes 3 unit, this becomes 2 unit, and here we had seen that if the total distance was d, so out of d, now see, out of d, that 3:2, the remaining distance would be divided, right? And in the first 3 hours, in the, I mean, total distance Rajdhani covers in 10 hours. So in 4 hours it would have covered 4 by 10th part, that is 2 by 5th part. So the remaining Mn part was 3 by 5th. So that 3 by 5th it would have again be further divided into 3:2 ratio. That is, and from there we could have found that what is the meeting time, right? So that we could have found. But Anyway, this LCM method is a very easy one, and so I recommend this method to be used if it appears in an examination. Now, question number 2, that in a marriage ceremony in a village, a person from a bride side fires two gunshots in air from same place at an interval of 10 minutes to welcome the groom. The groom, who was approaching the bride's village in a car but still some distance away, hears second gun shot 9 minutes 20 seconds after first shot. Find the distance of groom's car if it is given that the sound travels at 330 meters per second. So this is another important, conceptual problems based on relative motion. So let us see how to proceed ahead in this question. So it says that in a marriage ceremony, the bride side's people fire two gunshots. So let this location be the base. Let this be given as bride side, where the people from the bride side fires two gunshot. Let the first gunshot be fired at t is equal to 0. And just now they fired first gunshot, and the second gunshot they are firing after 13 seconds, right? After 13, sorry, it's here after 10 minutes. The second gunshot they are firing after 10 minutes. After 10 minutes. So what is it now? And here at some distance, let us suppose that here the groom car is there originally at t is equal to 0. At t is equal to 0, the groom car is here, right? So now when at t is equal to 0, the bride's family fires the first gunshot. At what time the shot would be heard by the groom's family or the groom in the car, right? So that is nothing but the time taken by the sound to travel this distance. Let this distance be d, right? So the time taken, so groom will hear this shot at t is equal to d upon d upon d upon the relative velocity of the two. Now see here, from here let us assume that sound travels at a velocity of vs, and groom is sitting in a car and car is moving this way. So let the velocity of car be vc. So what is the relative speed of the sound with respect to the car? That will be vs plus vc, right? We can say so. So the time taken by the sound to reach from point b to point g is nothing but d upon vs plus vc. So at this point of time, groom hears the first shot. Now after 10 minutes, the bride family again fires one shot, right? So now question is, now if the groom had been stationed here only, meaning that car was not moving, then exactly after 13 second, groom would have another, again heard the gunshot. But now see what happens. In 10 seconds, now the groom would not be here only. In 10 seconds, the groom at t is equal to 10, bride stays here only, bride's family. Whereas the groom's car would have traveled certain distance. That is, from here to here, they would have covered certain distance in 10 seconds, right? At a speed of vc. So this is nothing but 10 vc. In 10 seconds, at a speed of vc, this much distance the groom's car would have covered. So this is the new position of groom and this is the new position of bride. So at t is equal to 10 second, right? So at t is equal to 10 second, when the gunshot is fired, that sound will come here at another t dash. T dash is equal to now this distance. This is nothing but original d minus 10 bc, right? So this will take time. Time will be what? D minus 10 vc, distance upon the relative speed of sound with respect to car. So that becomes vs plus vc, right? So after this much time after the gun firing, it reaches here, and gun was fired at 10 seconds, so he would have heard this at 10 plus this second. So at this time the groom would have heard the shot, right? So now what happens? Now see, question is said that, so actually difference between t and t dash minus t has been given as 9 minute 20 second, 9 minute 20 second. So that means that it is given that t dash minus t is equal to 9 minute 20 second, and t dash is nothing but 10 plus d minus 10 vc upon vs upon vc minus t is equal to nothing but d upon vs plus vc, and this is given as 9.33 we can say, right? Or nothing but 9 whole 1 by 3, that is 23 28 by 3. So from here d upon vc will get cancelled, so what remains actually is this will come this side, so 2 by 3, 10 minus 28 by 3 is 2 by 3, and what remains here is 10 vc upon vs plus vc. So from here 2 cancels this out, so vs plus vc is equal to 15 vc, right? So from here we can say that vs is equal to 14 vc. So velocity of car is velocity of sound upon 14, that means 330 upon 14. So this we will solve what it comes, 330 upon 14, this is 23.57, 23.57 meter per second. And this is the answer to this question. Now see, we try to build up the concept, right? We try to build up the concept, otherwise the question can be solved in seconds. Now see, basically what does it mean? We try to see in terms of radiative motion that when the gun was first fired, it took some time to reach to the groom. What is that time? That it reached groom at d upon vs plus vc, where vs and vc are the respective speed of sound and the velocity of car. Now when after 10 seconds another shot is fired, but at t is equal to 10 seconds, the position of the bride remains the same, but the position of the gun, sorry, groom changes. Groom changes. The groom's car would have moved in those 10 seconds at a speed of vc by 10 vc. So now the distance between bride and the groom would have been only 10 d minus 10 vc, and to cover this distance as a relative speed of vs plus vc, it would have taken d minus 10 vc upon vs plus vc, add that over 10, so this gives a time stamp t dash, and difference between these two time stamps t dash and t is given as 12.5. We solved that, and given at as 9 minute 20 second, that is 9.33. We solved this equation and we got the value of vc as velocity of car as 23.57 meter per second. However, there's a, I mean, now see what we did basically on this story basically tells that the distance traveled by sound, the distance traveled by sound it means that distance traveled by sound in what, 9 minute 20 second and 10 minute, that is 40 second. So in 40 second is equal to distance traveled by car in 10 minutes, right? So simple. I mean, that is what it means, that the distance which the sound traveled in 40 seconds is same as the distance which the car traveled in 10 minutes. So that becomes 40 second into speed is 330 meter per second, and that should be equal to the distance traveled is nothing but velocity of car vc into 10 minutes. So 10 into 60. If we solve this from here, we get vc is equal to 23.57 meter per second, which is same as what we obtained here. But the method one was important to build the concept. However, from that concept we can derive that this shortcut, that distance traveled by sound in 40 second, that is in gap, that this 40 second is difference of the two, right? From 10 minute it got reduced to 9 minute 20 seconds. So that reduction is because of the distance traveled by sound in 40 second is equal to distance traveled by the car in 10 minutes, right? So that's it for this. Now we will move to question number 3. It says that a train of 1 kilometer length moves with a constant speed of 60 km per hour. Because of the glitch in the signaling system, the guard at the rear end of the train could not disseminate messages to the driver at the front end of the train. Hence, the guard decides to drive a car and reach the driver of the train, pass on the message, and returns back to the guard bogie at the rear end of the train. When he returns back, he notices that the train has traveled a distance of 5 km since the start of his onward journey towards the driver. Find the speed of the car which the guard drove. Now see, we'll first try to understand the scenario. Here is a train. So this is the guard's bogie and this is the driver's engine, right? So now what, because there's some fault in the signaling system, guard cannot relay the information to driver from here. So what happens? Guard takes a car here and he drives at a certain speed, right? That we do not know. That would be vc. Whereas the train moves at a speed of vt, velocity of train. So what happened in the first part? So basically, what has to be done? Guard has to reach from point G to point D, right, and then come back to G. So if we assume that find the, so let the velocity of car with respect to the velocity of train will be what? Velocity of car minus velocity of train. So in this case, if when we talk about velocity, relative velocity of car with respect to train, then we can assume that train is stopped and car is moving with her relative velocity of vc minus vt. So what is the distance the car has to travel? In that case, the length of the train n. So this is the distance which the car has to travel, n distance, right, at a velocity of vc minus vt. So what is the time taken in the onward journey? Onward journey will be what? And length is given as 1 kilometer, right? So 1 upon what? vc minus vt. Now time taken in backward journey, now suppose when the guard has reached here, guard will turn back and come to this point G. So now guard is moving in this direction, whereas train continues to move in this direction. So both are moving in opposite direction. So relative speed will be vc plus vt, and with respect to train, the guard has to cover the distance of n, which is 1 kilometer. So that time t2 in a backward journey will be again 1 kilometer upon vc plus vt. Now this is the total time. So in time t1 plus t2, the guard has gone to point D, met the driver, and come back again to guard D. So in effect, the total time t1 plus t2, he observed that meanwhile the train had moved 5 kilometer. So that is what that train has moved 5 kilometer. So basically, in time t1 plus t2, and train's speed is, we know vt is 60 kilometer. So we can say that 5 kilometer is the distance covered by the train in those t1 plus t2 time, right? Let it be 5 kilometer only. So these three equations we will solve around, and then we'll get to the answer. So what is it? This says that 1 upon Vc minus Vt plus 1 upon Vc plus Vt, T1 plus T2 is equal to, from here we can say 5 upon Vt, right? From here we can say 5 upon Vt. So if we solve this, we will find that 2Vc upon Vc square minus Vt square is equal to 5 upon Vt. So that means V, and here we will now substitute Vt is equal to given as 60 kilometer per hour. So if we substitute here, it becomes 2Vc upon Vc square minus 3600 is equal to 5 upon 60, which is nothing but 1 by 12. So if we further solve this equation, we will get a quadratic equation, that is Vc square minus 3600 or minus 24 Vc minus 3600 is equal to 0. So using the formula, we can get the value of Vc as 24 plus minus 24 whole square plus b square minus 4ac. So this becomes 4 into 36 is 144, 144 0 0 upon 2. From here if we solve, we get 24 into root 26 plus 1, right? If we solve this by 2, so basically this is nothing but 12 times root 26 plus 1, and root 26 we know is 5 point nearly 1. So if we solve that, we get that to be 73.19 kilometer per hour. This is the answer to this question. So again, it was an important one in a way. Like, see, the approach was that we had to consider the relative motion, wherein the guard was moving in the forward direction. He took time t1. That time t1 is nothing but the length of the train upon Vc minus Vt. Then again he came back. In that case, the relative velocity become Vc plus Vt. And in that t1 plus t2 time, in absolute terms, the train had moved 5 kilometer at a speed of Vt. So those three equations we solved, and then we got the answer. Now, coming to question number 4, this is a important and a difficult problem in a way to say. Now see, it says that two trains 150 miles apart are traveling towards each other along the same track. The first train goes 60 miles per hour. The second train races along at 90 miles per hour. A fly is hovering just above the nose of the first train. It budges from first train to the second train and turns around immediately, flies back to the first train and turns around again. It goes on flying back and forth between the two trains until they collide. If the fly's speed is 120 miles per hour, find the total distance covered by the fly. Also find the distance traveled by fly in the direction of the first train and in the direction of second train. So important question. We'll break it into many parts and then try to solve it using various methods. 2 or 3 methods we will see here. So this is one train. Let it be T1. This is another train T2. T1 is moving at a speed of 60 kilometer per hour, and T2 is moving in this opposite direction at, sorry, it's 90 mile per hour. And it is moving at a 90 miles per hour. Now a fly is hovering just above the nose of here. So there is a fly which is moving constantly going like this, then coming back. Now see, first of all, we'll try to see that fly will keep on moving to and fro till the time the two trains collide with each other or meet with each other. So the time, what is the time after which the trains collide? So that time is nothing but the distance between T1 and T2, that are one. This distance is 150 miles. So time will be 150 miles upon relative speed, that is 60 plus 90 miles per hour. That becomes again. So here I write it as 60 plus 90. So it becomes 1 hour. So in 1 hour time, in one hour time, the two trains will meet. And for all this 1 hour, the fly has been moving all through this 1 hour, either to or fro, right, at a speed of 120 miles per hour. So what is the distance covered by fly? Total distance covered by fly speed into total time it has flown. So this becomes 120 miles. So total distance covered by the fly is 120 miles, and that is the first part. If the fly speed is 120 miles per hour, find total distance covered by the fly. So this is the answer to the first part. Now the second part. Also find a distance traveled by fly in the direction of first train in the direction of second train. So let us see. Try to concentrate here. Say suppose this is the position of first train. So fly goes from here in the forward direction, reaches here, it meets the second train, right? And then from here it turns back, it comes here, right? Here it meets the first train here. Then again from here it will again go this way, and suppose it meets the second train here. From here it will again come back, and suppose it meets the first train for the second time here, right? From here it will again move towards the second train, and second train again hits the fly here for the second time at this location. From here fly will go. So this pattern will keep on following, right? This pattern will be followed. Now let us see, if we suppose denote this forward movement by F1, this backward movement by B1, this forward movement by F2, this backward movement by B2, this forward movement by F3, this backward movement by B3, and in this fashion there will be a point where this range would keep on narrowing and it diverges, I mean it merges to a point when the two trains meet. When the two trains meet, then hardly, I mean, fly can move to and fro. So that is a point where the fly will remain stuck, right? And what is this point? At what point? So this point can we say is from here, this point where the two trains meet is nothing but 60 kilometer, because the after 1 hour both the trains, this is the point where the two trains meet, and two trains meet after 1 hour. So from this point, from the first train which is moving at a 60 miles per hour, in 1 hour this will be a 60 mile distance. So total distance is 60 miles, right? This is the first concept. Now if we see the first gap here, this is nothing but f1 minus b1, we can say, right? F1 minus b1. Similarly, this second gap is f2 minus b2. Then this third gap is f3 minus b3, right? F3 minus b3. So these gaps, respective gaps, so if we just keep on adding these gaps, like f1 minus b1 plus f2 minus b2 plus f3 minus b3 plus so on. So the net all summation of all these will actually lead to this distance 60. So this will be nothing but 60 here, right? All these gaps, all these respective gaps, if added, will result to the final distance. This is 60, right? So this I can write as total f1 plus f2 plus f3 so on minus b1 plus b2 plus b3 and so on, that is 60. So this all f1 I can write as net f forward position, and all the summation of b's I can write as net backward position, net backward movement. So net forward minus net backward movement is 60 meters, and we know that the total movement of the fly is nothing but 120 miles. So f plus b, that is all the forward movements and all the backward movement combined, is 120 miles. So this, if we add from here, 2f is nothing but 180. So from here we can say f is nothing but 90. So forward movement is 90 miles. So from here we can say backward movement is 30 miles, right? So question was, find the distance traveled by the fly in the direction of first train. In the direction of first train, that is a forward movement, so that is 90 miles. The in the direction of second train, that is in the backward direction, that is 30 miles. So both these answers we have got, right? So all the story or the concept was there in this diagram, or the pattern in which the fly is moving, right? In the pattern in which the fly is moving. I draw this picture a bit more clearly. I mean, what do this? So this, now this distance, let this be f2 minus b2, and this gap is f3 minus b3. So similarly, the gaps gets on adding. So net gap f1 b1 f2 b2 f3 b3. So those becomes net forward minus net backward position, that becomes 60, and f1. How come this 60 came? Because now see, everything will converge to a point where the two trains meet, right? And what is that point? That is a point which is 60 kilometer from here. Why 60? Because the trains are meeting after 1 hour, and in 1 hour from this point, T1 at a speed of 60 miles per hour in 1 hour cover a distance of 60 miles, right? So from there we got this. Now we'll see another method to this, the same problem. Now see here. Here it is like fly goes in this direction, forward direction. I mean total, and a certain direction it will also go in backward direction, a certain part of a. So this is the net forward position, total forward movement by the fly, and this is total backward movement by the fly, right? And this distance is nothing but the distance traveled by the train T1, right? Distance traveled by T1 till the final position, and here is the position where the two trains meet, right? Because total forward minus total backward, here is the position where the two trains meet, and this position is nothing but the distance traveled by train T1 in 1 hour, which is 60 kilometer or 60 miles rather, right? 60 miles. Now if we look at here, what happens? Now if we see from the starting point, in the same time in which the fly covers the all the forward distances and backward distances, in the same time the train T1 covers from this point to this point, this dt1 distance, right? And since the speed of train is just half the speed of the fly, that is 60 and 120, so this distance, that is let me draw this in different color. So the distance in this green ink must be half of the distance, total distance in the blue ink, right? So if the total distance in the blue ink, so if this is 60, so let this be first x, right? X. So the distance in the blue ink will be what? 2x, right? Total twice the distance. So distance in this blue ink will be 2x. What is this 2x? This distance and this distance combined. And here x is given as 60. X is given as 60. So what is the total distance which the so the total distance covered, I mean this total distance would be what? 2x and plus this x, 3x, and this is just half. So the top portion would be top portion. This portion will be 3x by 2, and the bottom portion would be again 3x by 2. And out of this 3x, this green part is x. So what remains is this part, which is x by 2. So if this part is x, so what is, and this top 9 has, we have already written 3x by 2. So we can say that the total forward distance upon total backward distance is what? 3x by 2 upon x by 2. So that is nothing but 3:1 ratio. And the total distance anyway we know f plus b is 120 miles. 120 miles. So we can say that forward upon backward in the ratio of 3:1. So forward would be what? 3 by 4 into 120, which is nothing but 90 miles. And backward from here will be nothing but 30 miles. And again redraw this figure, and again draw this figure here. So from here the fly goes net forward distance this much, and then again returns back to say this position. And in the meanwhile the train will cover this much distance, right? So let this distance be x. So in the same time the train has covered this x distance, the fly will cover the 2x distance. So the distance in red will be what? 2x, right? 2x. So total distance becomes what? 2x plus x is 3x. Total distance becomes 2x plus x is equal to 3x. So of this 3x, the top distance, I mean, because both this is net forward and this is same. So this will be 3x by 2, and the bottom will also be total will be 3x by 2. Out of this 3x by 2, this green is x. So what remains here is x by 2, this bottom red part. And the top red part is 3x by 2. And top red is nothing but this is the forward distance, and bottom red is nothing but the backward distance. So we can say that forward upon backward distances, the ratio is 3x by 2 upon x by 2, which is 3 by 1. And total distance we know is 120 miles. So therefore we can say that the forward distance covered by the fly in the time the two trains meet is nothing but 90 miles, right? 90 miles. So this is another way of solving this question, or a very similar interpretation again we can see here. Now see, uh, say for the first meet, I mean what happens? Here is a train and here is another train. The fly start from here, meets the second train here, right? By the time it comes here, the second train would have come here, and then again the fly gets back and comes here, right? Fly from here gets back and reaches here and meets the train, first train here. First train would have come here by then. So in the time this is the distance covered by the train 1. In the same time the fly has gone to this distance and come back. And since the speed of the fly is twice, so we can say that the distance, this distance is nothing but, if this is x, so the distance in blue plus this bottom part red is nothing but 2x. So from the same part we can say this is again 3x by 2, this is x by 2. So for every meet with the first train, between every consecutive meet with the first train, the fly would have covered 3x by 2 plus x by 2, which is nothing but 2x, right? So for every meet, between every meet, we can say that between every two meet with the first train, we can say that the fly is covering a forward distance of 3x by 2 and a backward of x by 2. And this pattern will be true for all the subsequent meets of the fly with the first train. So we can say that for every for between every meet, the forward distance covered and the backward distance covered, the ratio is nothing but 3 is to 1. So therefore, the total forward distance plus backward distance combined is 120. So total forward distance will be nothing but 3 by 4 into 120, which is 90 miles. So this is another interpretation very similar to what we have seen so far, and this way we can solve this question very easily. Uh, this may not be very easy. This is a difficult question, difficult in nature, but with the concepts built around this, now I hope that the concepts and the understanding becomes much more clear. Now moving to question number 5, it says that a superfast train traveling at 90 km per hour starts overtaking a passenger train T1 traveling at 54 km per hour at 4 p.m. and overtakes it in 120 seconds. So let us see. At time T1, at time 4, at 4 p.m., there is a train, right? Passenger train moving here, and this train is T1. This is moving at a speed of, I think we do not know. Let us read the full question first. Then the superfast train travels exactly for an hour and starts crossing another passenger train T2 traveling at 36 km per hour in opposite direction. When will the second passenger train T2 meet the first passenger train T1 if it is given that the length of the train T1 is 400 meter? So this T1 is given as 400 meter, right? This T1 is given as 400 meter, and the speed of T1 is 54 kilometer per hour, and there is a train, superfast train, which is at 4 p.m. starts overtaking this train T1. This is a superfast train, right? And the speed of superfast train is given as 90 kilometer per hour. So this is a status as on 4 p.m. Now after 20 seconds, that is at 400, sorry, 120. So that means 402. At 402 p.m., what happens? The train would have moved, this train, the T1 train would have moved certain distance ahead. So let us this, the train is here, right? T1 train. And at that time, the superfast train has crossed this and the train is here, the superfast train. And now after this, the train runs for 1 hour. After this, train runs for 1 hour. So that is at 5:02 p.m. In 1 hour, what happens? The rear end of the train would have covered a distance of what? At a speed of 90 kilometer per hour, 90 kilometer distance from this distance to this distance, 90 kilometer, right? The rear end. So the train would be somewhat like this and starts crossing another train T2 traveling at 36 km per hour in opposite direction. So there is another train coming here at 36 km per hour in opposite direction. So now let us see what is the total status as of now. So at 5:02, and we have to find when will the second passenger train T2 meet the first passenger train T2 T1. If it is given that the length of the train T1 is 400 meters. So now try to see here. At 4:02, train T1 is here, right? And we have to find when the two trains, that is T1 and T2, let this be T2, T1 and T2 meet each other. And T1 here is at 54 kilometer per hour and T2 is 36 kilometer per hour. When will the two trains meet? For meeting, their front ends should meet each other, right? So for that, we should get the distance between these 2 points. So what is the distance between these 2 points? That is nothing but 90 kilometer distance and plus this length of super fast train. And this we do not know, right? So because from 4:02 to 5:02, the train, super fast train has covered 90 kilometer. But yeah, but in this 1 hour, this train has also, the T1 train has also covered certain distance. So T1 train would have covered a distance at 54 kilometer here, right? So this rear end would have come 50 kilometer or here. So we can say that it would have covered 50 kilometer, 54 kilometers. So this would be the Victorian graph, right? So basically at 5:02, this is the position of the, yeah, and this distance is 54 kilometer. Or this position, we can say, if this is here, so the front end here is, this is 54 kilometer, right? Between the two ends of the engine of the train T1, the distance is 54 kilometer, right? Distance is 54 kilometer. So now see, at 5:02, this train T1 is here, the front end is here, and the train T2, the front end is here. What is the difference between the two, right? This is here at a length of, this is, say suppose if this was zero position, so this position is nothing but 90 plus n, right? And if this is 0 position, so this is 54 kilometer position, right? This is 54 kilometer position. So the distance between the two trains, the distance between T1 and T2 is nothing but 90 plus n minus 54. So that becomes 36 plus n kilometer distance between the two. And the speed of the two we know, that is Vt1 is 54 kilometer per hour and Vt2 is 36 kilometer per hour. So when they are moving together, now at this 5:02, they are at a distance of 36 plus n kilometer with the respective speed of 54 kilometer per hour and 36 kilometer per hour. So what is the time they will meet? The time taken after 5:02. So this is the position at 5:02 p.m. So time taken to meet will be nothing but 36 plus n upon the respective speed of 36 plus 54, which is 90. So 36 plus n upon 90. So now if we know the value of length n of superfast train, then we can find the answer to this question. So let us now find the value of n. For that we need to use the first information, which is given as 120 second. So superfast train crosses the the passenger train T1 in 120 second in the moving in the same direction. So we can say that n plus 400 is the total distance covered, relative distance covered between the two train, and that at a distance of relative speed is 90 minus 54, right? And this is in kilometer per hour. So this I can convert to meter per second by multiplying by 5 by 18 and in a time of 120 second. So this is what? 90 minus 54 is 36 into 5 by 18 into 120. So this is n plus 400. From here we can get this is 1200. So from here we get n is equal to 800 meter. So now value of n we have found out. So this thing we will take calculate here. So from here we can say time is nothing but time taken after 5:02 p.m. Time taken is equal to 36, that is kilometer. Okay, this is kilometer, and this becomes 800 meter. So this is nothing but 36 plus zero point 0.8 upon 90, right? Upon 90. So that is nothing but 36 upon zero point 0.8 upon 90 in hours. So let us calculate what does it come. So this is nothing but 36.8 divided by 90. So this is 24 minutes. This is 24 minutes. 32 seconds. So this comes as 24 minute 32 second. So what is the time stamp? Time of meeting is 5:02 plus this duration. So 5:02 plus 24 minute 32 second, that is nothing but 5:26:32. So this is the answer to this question. So this is conceptually a good question. Herein we just need to be careful at what time we are taking or looking at the thing. I just revise shortly what I did here. In brief, we can see that at 4 p.m. the superfast train starts to overtake the passenger train T1, right? That overtaking finishes in 4:02 at 4:02. So at 4:02, this is the this is the passenger train, and superfast train has just crossed this, right? This is the superfast train at here. The rear end of superfast is same at the same length level as the engine of the passenger train. Now after 1 hour, that is at 5:02, in 1 hour the front end or the rear end of the superfast would have traveled 90 kilometer. So here is the rear end, and the front end would be n distance ahead. If the length of the superfast is n, assumed to be n, length of superfast is equal to n. So this is the position of superfast train, and at this junction it starts overtaking another passenger train T2, right? So just the engine of T2 is at this level, and in this 1 hour the engine of T1 passenger train would have covered 54 kilometer at a speed of 54 kilometer per hour. So let's suppose it falls here. So 54 kilometer is the engine, right? So now they will be meeting when the two front engines meet, T1 and T2, and this distance is nothing but if this is assumed to be 0, this length is 0. So from here this is 90 plus n, this is 90 plus n, and this is 54, right? So this distance would be what? 90 plus n minus 54. That is what I did. 90 plus n minus 54 is the distance between the two passenger train which they have to cover to meet at a relative speed of what? 54 plus 36, 90. So right, 36 plus n upon 90. Now we have to find n. For that we know that since the passenger train 1 was overtaken by superfast train in 120 seconds, therefore from here we can use the given set of data moving in same direction, so the relative speed will be 90 minus 54. So the length we obtained is 800 meters, right? 800 meters. So we will use this length of the superfast train here to obtain the answer to this question. So that is a solution to this question. Now let's move to question number 6. Question number 6 is another important one, but relatively easy than what we have been doing so far. Actually, a problem of this nature we already saw a couple of questions back. So let us see. There's a robbery in a shop, and when the police reaches the destination, the thief is 5 kilometers away. The speed of the thief is 10 meter per second, and the police is 20 meter per second. As also the police has a dog which continuously runs between the police and the thief at a speed of 30 meter per second to give the police information about the thief. Find the total distance covered by the dog and the distance covered by the dog in the forward direction. That is in direction of police. Same as what we did a problem, a similar nature, where a fly was moving to and fro between two trains moving in opposite direction. So let us see. So what happens here? There's a robbery in a shop, right? So let's this pointer represents shop, and when the police reach here, the thief was already at a distance, and this distance is 5 kilometer, right? So this is shop, and this is the distance where the thief is present. So now what happens? And both are running here in same direction, right? Both are running here in same direction. It's not that in like in earlier problem, both the trains were running towards each other. Here they are running in the same direction. So here from point S, police starts at a speed of 20 meter per second, and at this time, the thief is running at a speed of 10 meter per second, and this distance is 5 kilometer, right? 5 kilometer. So what is the time taken by police to meet? Time taken by police to meet the thief is nothing but total distance 5 upon the relative speed velocity of police with respect to thief. So that becomes 5 upon 20 minus 10. That becomes, sorry, this is in kilometer, this is in meter per second. So we make it say 5000 meter. So 5000 upon 10. So that is 500 second. So the first part of the question, you find the distance covered by the dog. So what happens? Police has a dog. The dog keeps on running between the, goes here, comes back, from here goes some distance, again comes back, from here goes some distance, again comes back. So thereby the dog keeps on running to and fro to the point such that police catches the thief, right? Police catches the thief. So here exactly the figures would be something like this. Suppose catches the dog catches the thief first time here, right? So from here it will, dog will come back here. The police meets the dog. From here again dog runs, and suppose it catches here, right? The thief here, and then again dog comes back. From here dog again goes, and suppose it catches the thief here. Here it meets the again. So this fashion, this will be the type of a pictorial representation of the movement of dog in this case, when the two uh, entities, that is police and the thief, are moving in the same direction. So let us see. Here we'll come to this later. First what happens? First what happens? That dog therefore moves for what? 500 second, total 500 second at 30 meter per second. So distance covered by dog is nothing but time into speed, which is 15,000 meter, which is 15 kilometer. So in the whole process, till the time police catches thief, the dog has covered a distance of 15 kilometer. This answers our first part. Now for the second part, we will again now try to interpret the problem, this pattern of movement of dog. What happens? So dog is moving a certain forward distance, right? And then a certain backward distance. So the total forward distance by the dog, and the total backward distance by the, let me represent the backward distance by green shade. And now this is the distance covered by the police to catch the thief, right? Distance covered by police. And this location is nothing but this point is the point where police catches thief, right? So what is the distance represented in blue line? This x will be what? The distance covered by the police in catching the thief, right? So police catches the thief in 500 seconds at a speed of 20. So this is nothing but 10 kilometer, right? Or 1000 meter. So this x is 1000 meters. And now since the speed of in the same time, since the speed of dog is 3 by 2 times the speed of police, so the distance covered by dog represented in the red and the green line, so that f plus b, f plus b total will be what? 3 by 2 into x, right? 3 by 2 into x. So total distance, so therefore total distance by police and dog is what? 3x by 2 plus x, right? Sorry, let it be 2x. Police covers 2x, then uh, dog will cover 3x, right? So this becomes more intuitive now. So total distance covered will be 5x. So if this distance covered by police, this dp is 2x, so therefore the distance covered by the dog will be this forward plus backward movement, so that becomes 3x to make it in a ratio 3 is to 2, that is in ratio of the speed of the dog is to police. So now total distance is 5x. So can we say the top portion f will be nothing but 5x by 2, and the bottom portion will also be 5x by 2, the way we did in the previous problem. And of 5x by 2, this blue part is 2x. So what will be the backward portion? So b, can we write b will be nothing but 5x by 2 minus 2x, which is x by 2, x by 2. So therefore we can say that, and f is nothing but 5x by 2. So we can say that f is equal to 5x by 2 and b is equal to x by 2. So therefore net forward to backward ratio is 5 is to 1. So net forward movement by dog is nothing but 5 by 6 into total movement is 15 kilometer, right? So this becomes 12.5 kilometer. This is the answer, right? So out of the total movement by dog of 15 kilometer, it moved 5 part of that, 5 by 6 part of that movement in forward direction, that is 12.5 kilometer. So that is a answer to this question. Same as what we did in the previous thing. Only thing, I mean, the method or the concept we use the same, but the pictorial representation would be a certain different. I mean, here because both are moving in the forward direction, so it will be extending towards the right hand side. Now moving to question number 7, another important problem and a slightly difficult one also. So let us see, we'll spend some time over here. Jodhpur Express covers a total distance of 450 kilometer between Tundela Junction and Mughal Junction. The train leaves Tunda at 1 p.m. and reaches Kanpur at 4 p.m., which is 90 kilometer far. Further, the train reaches Allahabad at a distance of 180 kilometer at 8 p.m. This 180 kilometer is from Kanpur, and finally arrives at Mughal Sarai at 10 p.m. Also, one passenger train starts every hour from Mughal Sarai for Tundela starting 5 a.m. in the morning. The last such passenger train leaves Mughal Sarai for Tunda at 7 p.m. If it is given that the passenger trains run at uniform speed of 45 km per hour, find the total number of meets between Jodhpur Express and passenger trains. Then minimum possible time interval between two consecutive meets and the maximum possible time interval between two such consecutive meets between passenger train and Jodhpur Express. So let us first try to understand the problem and then we will move ahead with the solution. So I will try to draw the problem first. So let this be Mughal Sarai Junction. Rather, let this be Tundna Junction. At a 90 km distance is a Kanpur Junction. So this patch is 90 km. After here, 180 km after this place. After 180 km from Kanpur is Allahabad station, and after 180 km from Allahabad we have Mughal Sarai Junction, right? And the time at which the train and from this side we are showing it for Jodhpur Express, Jodhpur Express, which runs at a speed, different speed it will be running. Total distance therefore become, how come this 180 becomes, because 450 minus 90 minus 180 is this 180, right? Now train leaves Tunda at 1 p.m. So here at 1 p.m. train leaves Tunda and reaches Kanpur at 4 p.m. Here it is at 4 p.m., which is 90 km far. Further, the train reaches Allahabad at 8 p.m. and at Mughal Sarai at 10 p.m. Right. So can we find the speed? Can we find the speed between each patch? So this 90 km in 3 hours. So speed becomes 30 km per hour. For K to A, Kanpur Allahabad patch 180 km in 4 hours. So that becomes 45 km per hour. This we have to calculate. Then again for Allahabad Mughal Sarai, which is 180 km patch, in covered in 2 hours. So average speed becomes 90 km per hour. So average speed also we could calculate. Now let us, this is for Jodhpur Express. Now what happens? There are some passenger trains which starts from Mughal Sarai. So first passenger train starts at 5 a.m. Second starts at 6 a.m. every hour. Then 7 a.m. Then 8 a.m. so on till 6 p.m. and the last one is at 7 p.m. Right. So how many trains are there then in total? How many trains are there then? From 5 to 7 it becomes 15 trains, right? 5 plus 7, 12 hours, 12 plus uh, this 7. So total 15 trains we have, right? So total 15 trains. How come from, I mean, we can just count the difference. No, 5 to 12 is 7 and from 12 to 7 is 7, and including both the ends that we add 1. So basically it becomes 15 trains in total. 15 passenger trains starts from Mughal Sarai in a day, right, at different times, moving towards Tundela Junction. So now see, the number of meets will certainly be either equal to 15 or less than 15. We will have to check whether all the trains meet Jodhpur Express on the way or not. So if we can check for the extremes, that is the first train and the last passenger train, if those two trains meet, then we can be certainly sure that in the middle train will also be meeting somewhere, right? So we just check for the first and the last train. How come? This 5 a.m. train, 5 a.m. train, and all the passenger trains run at a speed of, it has been given at 45 km per hour. All the passenger trains run at 45 km per hour. So now see, So we are checking for the first 5 a.m. passenger train. Passenger train. By 1 p.m., when Jodhpur starts Tunda, the passenger train had covered what distance? 45 into from 5 to 1, that is 5 7 plus 1 8, 360 kilometer, right? So it already had covered 360 kilometer, the first train. So and so at 1 p.m. the Jodhpur was at Tunda junction, whereas the first passenger train was 360 kilometer from Mughal, that is at Kanpur junction, right? So certainly these two trains will meet, and these two trains will meet at some time. What is that time? So the meeting time will be remaining distance is 450 minus 360 upon the average speed at 1 p.m. At 1 p.m. The speed of Jodhpur is 30 plus the speed of passenger train is 45, right? So this becomes 90 upon 75. This is hours. So to convert to minutes, we will multiply this 15 5 yeah, 15 4 yeah, and this 5 18. So this is 72 minutes, right? This is 72 minutes. So first train meets this. Now let us check for the second train. Does the second train meet? Sorry, the last train. Last train starts at 7 p.m. So let us check the position at 7 p.m. Where does Jodhpur is? So at 7 p.m. Jodhpur is at what? I mean, Jodhpur started at 1 p.m. So by 7 p.m., that is in 6 hours, 7 p.m., it is somewhere in between Kanpur and Allahabad, right? And at that time, this train is starting from here. So certainly this will be meeting. So we can safely say that even the last passenger train will also meet Jodhpur. Jodhpur Express. So when the first or the last passenger train from Mughalsarai meets Jodhpur, so safely we can say that all the trains meet. So total number of meetings is what? On the number of trains, the number of trains becomes the number of meetings. So that is nothing but 15 is the answer to the first part, right? So 15 trains leave from Mughalsarai. All the trains will meet Jodhpur on the way. Jodhpur is moving from Tunda to Mughalsarai, and these trains, passenger trains, are moving from Mughalsarai to Tunda. So that is the first answer to the first part. Now, minimum possible time interval between two meets and maximum possible time interval between two meets. So for this, we will what we will do. I mean, conceptually, if we look, what is the time interval between two meets? Time interval is basically nothing but see that we will see on the next slide. So let us see here. Time between meet is nothing but relative distance upon relative speed, right? This we can say. I just redraw this figure once again here. Tunda, this is Kanpur, Allahabad, this is Mughalsarai. This distance is 90 kilometer. This is 180. This is 180. Train starts from here 1, and then 4, 8, 10. 4. This is 8 a.m. Sorry, p.m. This is 10 p.m. 1 a.m. The speed becomes 30 kilometer per hour. Here it is 45 kilometer per hour. Here it is 90 kilometer per hour. Right? These are the speeds given. And then there are certain trains which starts from here at starting 5 a.m., 6 a.m., 7 a.m. till I think it is at 6 p.m. and 7 p.m. So total 15 trains running at 45 kilometer per hours. Right, 15 trains at respective time. So the question is find the minimum time between two successive meets or the maximum time. So we know that time between the meet will be nothing but the relative distance upon the relative speed. So and for a moment we will assume that relative distance is same. How that we will see going forward. So the time basically depends upon relative speed. What is the relative speed? Relative speed initially is when Jodhpur is moving at a speed of 30 km per hour, and this is at 45. So relative speed is 75. In this patch, the relative speed is 90, and in this patch, the relative speed is 135. So higher the relative speed, lower will be the time between two meetings, right? So from common sense, we can say that, or from very intuitive understanding, we can say that higher the relative speed or the higher the speed of Jodhpur Express, more frequent will be the meet with the passenger trains, and lower the relative speed, less frequent or after higher duration will be the meet with the passenger trains. So with this in background, now we will let us solve when will be the first meet. So that first meet we had calculated, the first train had met at 72 minutes, right? 72 minutes after 1 p.m. 72 minutes after 1 p.m. So first meet is nothing but 1 p.m. plus 72 minutes, which is nothing but 1 hour 12 minute. So first meet is at 2:12 p.m. Right? This we can say. Now what? Now let us see. So at 2 o'clock, somewhere around 2:12, the two trains meet. Right at this junction, at this point. But this is the status of first passenger train P1. But P2 will be what? P2 will be just 1 hour behind here, 1 hour at 45 kilometer per hour. So P2 will be 45 kilometer behind P1, and this at this position we have P1 and Jodhpur both have met each other at 12 p.m. Both the trains passenger 1 and Jodhpur have met, and passenger 2 is just 45 kilometer behind. So now for the next meeting, what happens? Next meeting, Jodhpur and P2 has to cover 45 minutes, 45 kilometer, and at, at 212 the speed of Jodhpur is 30, so the relative speed becomes 30 plus 45, right? So this is nothing but, and into 60 we will do to get into minutes, so this becomes 45 upon 75 into 60, so that is after 36 minutes. So after 36 minutes means 2:12 p.m. plus 36. So we get 2:48 p.m. The second meet happens. Then third meet. Now, so suppose at this junction, that is at 2:48. So at this junction, suppose J and P2, J and P2 meets, right? So just 1 hour behind that P3 will be here. P3. So 1 hour means 45 kilometer. So just 45 kilometer behind P3, third passenger train would be here. So Jodhpur and third passenger train will cover a distance of 45 kilometer, meet after a time which is again 45 upon the now see. The third meet happens here. Third meet happens at 2:48 and 10:238, that is 10:04 p.m. The speed of Jodhpur is 30 only. So 30 upon 30 plus, I mean 45 upon 30 plus 45, so same as 36 minutes. So it becomes 248 plus 36 minute. So this becomes what? 3:24 p.m. And similarly, fourth meet will be what? 3:24 plus again after 36 minute, which is nothing but 4 p.m. So now we have seen that the distance between the Jodhpur and any other, I mean, the next passenger train is always 45 kilometer. That we have seen, and that is what I told here. Here, that relative distance between the Jodhpur and any other passenger train will remain constant. That is 45 kilometer. Now, notice here, the fourth meet has happened at 4 p.m. The fifth meet, fifth train is 45 kilometer away, but the relative distance now is changed because at 4 p.m. the speed of the passenger train is 45 kilometer per hour, and the speed of the Jodhpur is also 45. So relative distance is 90. 45 by 90. So fifth meet, it will be nothing but 4 p.m. plus 45 by 90, which is nothing but 4:30 p.m. Right, 4:30 p.m. Now sixth meet will be again after half an hour, because till 8 p.m. the relative speed will now remain same. So it will be again after 4:30 plus 30 minutes, that is 5 p.m. Seventh meet again we can say safely at 5:30. Eighth meet at 6 p.m. Ninth meet at 6:30 p.m. Right. Then 10th meet at 7 p.m. 11th meet at 7:30 p.m. after half an hour. Till 8 o'clock it will be after half an hour. 12th meet after half an hour, that is at 8 p.m. Now we should be careful. After 12th meet, that is at 8 p.m. The next train is again okay, true that it's at 45 kilometer distance, but the relative speed is now changed. At after 8 p.m., the speed of Jodhpur is 90 kilometer per hour, whereas the speed of the passenger train coming from the opposite end is 45. So relative speed becomes 135. So 45 upon 135 is the next. Yeah. So from here we can say that 13th meet will be what? 8 p.m. plus 45 upon 45 plus 90. So this is nothing but 20 minutes. This part is 20 minutes. 1 by 3 hours, that is 20 minutes. So that becomes 8:20 p.m. Then 14th meet is again after 20 minutes, so that is 8:40. And 15th meet is at 8:40 plus again 20 minutes, which is 8:60, which is 9 hours, 9 p.m. So and total 15 meet will happen, right? So total 15 meet, and on the meeting we have seen that after what time interval every meeting is happening. So the first 4 meetings happens after a difference of 36 minutes, right? 36 minutes. Then the next 8 meetings happen after a difference of 30 minutes, and then the last 3 meetings happens after a difference of 20 minutes. So the question was what is minimum possible time interval between two consecutive meets? So minimum possible is 20 minutes and maximum possible is 36 minutes, right? Minimum possible is 20 minutes and maximum possible is 36 minutes. This we have seen as an answer, right? Minimum possible when the speed was maximum, speed of Jodhpur was maximum, then we saw the minimum possible difference, that is after every 20 minutes the trains are meeting, and when the speed of the Jodhpur was lowest, that is 30 km per hour, they were meeting after 36 minutes. So with this funda or the concept in mind, we could solve this question. This is certainly a difficult question and is not expected in CAT, though it may appear, or but certainly in JAT these sort of questions do appear time and again. So we should be very mindful, but nonetheless, irrespective of exam, from the concept wise, this is very important, and we should know that how to interpret a question of this nature, right? So therefore, now we'll move to the next problem. I believe this is the last question of this session. So here the question reads that a person hitting a target which is 465 meter away hears the bullet strike it 4.5 second after he has fired. A spectator equidistant from the target and the shooting point, but out of the danger line, hears the bullet strike 3 seconds after he heard the sound of the gun. Find the speed of the sound. So let us first draw this pictorially. What does this say? So this is, say, suppose person is hitting a target. Suppose, okay. So here is the target. Person shoots a gun towards this target T, right? And there is a spectator S who is sitting equidistant from P and T. So this distance is D and ST is also D, right? And PT is given as 465 meters. Now see, when person fires the gun, fires the bullet, so the time taken, so it's given that the same person hears the bullet strike the target after 4.5 seconds. So what would happen? For first person fires the bullet. So bullet from here, it goes to the target, hits the target, and then the sound travels back to the person here, right? Then only the person hears. So person fires the bullet. Bullet travels physically from point P to point T, then hits the target. That sound actually comes back to the person here at P, and this total time is given as 4.5 seconds. So let us write a equation for this, how to draw this. So this is nothing but 465 meter. The first movement is by bullet, and this is by sound. So let us speed of bullet be VB. So at a speed of VB, the bullet travels to T. So time taken is 465 by VB plus the same distance 465. The sound travels, that is Vs, and therefore these two times sum together is given as 4.5 second. This is the first equation. Now a spectator equidistant from the target and shooting point hears the bullet strike 3 seconds. So now when bullet is struck, when will spectator hear? Time at which a spectator hears bullet. So that time is, say, T1 is equal to nothing but D upon velocity of sound, right? From here, the person fires a bullet, that sound will also flow to S. So that velocity of sound becomes the time. And the time at which a spectator hears bullet striking target. So that means that what is the time after which the spectator will hear the bullet striking the target? For in that case, what will happen? The bullet will first travel from P to T, that is P to T movement by bullet, and then from T to S movement by sound, right? this is the total path traveled. So here what will happen, the bullet will travel from point P to T, that is 465 by VB, plus from T to S, let me draw this, uh, P to T, and then T to S. P to T, bullet travels, and from T to S, sound travels. So first part will be 465 by VB, and from T to S it will be what, D upon Vs. So this is T2, and it is given that T2 is nothing but T1 plus 3 second, right? He hears it after 3 second. So basically if we can solve this, it becomes 465 by VB is equal to, sorry, plus D by Vs is equal to T1 is D upon Vs plus 3, right? So from here D by Vs cancels out. So we can say that 465 by VB is equal to 3. So now we will substitute this second equation in this first equation. We get 465 by Vs is nothing but 4.5 minus 465 by VB, which is nothing but 3. So this becomes 1.5. So from here we can say velocity of sound is 465 upon 1.5, and that is, I think, 15 3 ja and 1. So 310 meter per second is the answer. Right. So just the movement of the respective items, either the bullet or the sound, we needed to consider here. Which person is hearing what, and which sound. I mean, is it the sound of a bullet or a sound of a bullet is striking the target, right? And those two things, if we can differentiate, then we'll be able to solve the questions. Otherwise, it's just the equation of a time, speed, distance that we did. So hope this was clear enough. This is the last problem of the session. So thanks for watching this video. Any query you can get back to us. We'll see you in the next session. Thanks.